equation of a circle, if you remember, is x squared plus y squared equals r squared. So in our case, it's going to be x squared plus y squared equals 9, since our radius is 3. And I wanted to show how we could tackle finding this derivative. Well, probably the first thing we'd want to do in our, the way we're used to doing it is get a y equals. So let me, in the interest of space, let me just kind of, rely on the fact that I think you can handle this. It's going to be the square root of 9 minus x squared. I put the plus or minus out there. I'm going to kind of ignore that. I'm going to put just a little bubble around. I'm going to kind of ignore that as I find the derivative. But that's essentially it. It's the square root of 9 minus x squared. And again, you can do that with your algebra to get a y equals. Knowing that I'm going to need the derivative, I'm going to rewrite this as 9 minus x squared to the 1/2 power. Okay? So my derivative bring the 1/2 out front, leave the inside alone. Now it's to the negative 1/2, and multiply by the derivative of the inside, which is negative 2x. Well, let me clean it up just a little bit here. Negative 2x is on the top. So 2 square root of 9 minus x squared on the bottom. Of course, negative 2 divided by 2 is just 1. So, get negative x over the square root of 9 minus x squared. There's my derivative. Now, what's interesting about this, of course, is that when I say find the slope at 2, well, here's 2, but here's 2. You might guess that the slopes will have the same absolute value. You'd be correct. If one is positive 1, the other is negative 1, they're going to have the same absolute value. Well, if I plug 2 in, I get negative 2 on top, and 9 minus 4, so I get negative 2 over the square root of 5, a negative slope. So it gives me this slope right here, the one that's negative. So then the question becomes, well, how would I get the slope here? Well, that's where that plus or minus came in. Remember I said just ignore it? Well, this is where it comes in, where we're actually going to need to think about it. Okay? Now, there is another way to do this. Let me go back to the very beginning. X squared plus y squared equals 9. And I want to just make a couple of notes here, a couple of things to think about. Number one, y is a function. That's how we always define y. We're always doing, y equals. Y is a function. And the other note is we want the slope, meaning dy dx. Okay? Remember that. Y is a function. The reason I'm harping on that is, up here we had 9 minus x squared to the 1/2. We had a function raised to the 1/2. When we did the derivative, we brought the 1/2 out front. We dropped the power, but we left the function. But then at the end, we had to multiply by the derivative of the function. That's how we handle it. We use chain rule. That's how we do the derivative of functions. Okay? I'm going to find the derivative right here. Right from here, x squared plus y squared equals 9. The derivative of x squared is 2x. The derivative of y, your probably first reaction is 2y. You're almost correct. Okay? Y is a function. I bring the 2 out front. I drop the power by 1. But just like back up here when I was doing the derivative, where I drop the power out front, reduce the power by 1, I then have to multiply by the derivative of the function. Well, the derivative of the function y is dy dx. Okay? One more time, let me just explain that. This is because it's chain rule. That's why we do this. We bring the 2 out front, we reduce the power by 1. But y is a function, so using chain rule, we do derivative of the outside, leave the inside alone, and then we have to multiply by the derivative of the inside. Y is our inside. Okay. And of course the derivative of 9 is 0. So remember, we want dy dx, so the first thing we do is subtract 2x from both sides. Then we divide by 2y. So we end up with negative 2x over 2y, which reduces to negative x over y. And this is our derivative. We'll take a look at this. We said that y was the square root of 9 minus x squared. So our derivative came out to be negative x over y. Negative x over y. We got the same thing. We didn't need to get a y equals equation. Getting a y equals equation is called explicitly deriving this. Not getting the y equals is called implicitly deriving this. Let me explain why this could be really useful. So our derivative is negative x over y. And again, you know, when I say I want the slope at 2, the one drawback is I plug in 2, I'd still need to figure out what y is. I'd probably use the original equation and figure out, you know, okay, 2 squared plus y squared is equal to 9, and you'd have to actually solve for y. And some people say, well, that's no different than what I had to do before. But think about this. If I asked you, where is the slope equal to 0? I think we'd look at the graph and say, well, it's up here and down here. That's where the slope is 0, those two spots. So when x is 0, because 0 divided by anything is 0. That gives us a 0 slope. Okay, so that's kind of nice to be able to look and say, oh, whenever the numerator is 0, I have a derivative of 0, meaning the slope is 0. If I said, where is the slope undefined, well, here it's vertical. Here it's vertical. It's when y is 0. And we can't divide by 0. So how do we, where do we look for verticals? Vertical tangents? Whenever the denominator is 0. That's kind of nice. It's a nice, easy equation. Okay? The slope is 0 when the numerator is 0, because that makes the derivative equal to 0. The slope is undefined when the denominator is 0, because that makes the derivative undefined. Now, a lot of times people say, well, I just like to keep doing it the way I've been doing it, but then we run into something like this. Okay, x cubed plus y cubed minus 9xy equals 0. Obviously, there's no way you can get an explicit equation out of this. We can't get just a y equals like we could with the circle. So we have to do this one implicitly. So let's find the derivative. I'm going to do the derivative right down here. The derivative of x cubed is 3x squared. The derivative of y cubed is 3y squared dy dx. Okay, remember, it's just chain rule. Okay, we drop the power out front, reduce the power by 1, and then multiply by the derivative of the function, the inside. So 3y squared dy dx. Now some people will say, well, anytime I take the derivative of y, I just put a dy dx. Essentially, yes, but it is chain rule. Okay, minus 9. Now, right here, x multiplied by y, we're going to need product rule. I'm going to put that in parentheses, okay? So I'm going to have first multiplied by derivative of the second. Well, derivative of y is just dy dx. Plus the second multiplied by derivative of the first, which is just 1. And the whole thing is still equal to 0. Let me make a pass here, get rid of parentheses. 3x squared plus 3y squared dy dx Now, I want to solve for dy dx. First thing I'm going to do, subtract 3x squared to the other side. I'm going to move everything that doesn't have a dy dx. So I'm going to then add 9y. Okay. The old algebra trick. Anything you don't want, move to the other side. Next, you notice that both of the terms left have a dy dx. I'm going to factor that out. Dy dx, so 3y squared minus 9x is in parentheses. That's equal to negative 3x squared plus 9y. Now I'll divide both sides by 3y squared minus 9x. And here's my derivative. Now I could reduce that. You'll notice that every single term has a 3 in it. So as I write it back up here by find dy dx, let me do that. I'm going to have negative x squared plus 3y over y squared minus 3x. Negative kind of lost there. Okay. So now, if I want the tangent line, and I want you to just look up here at the tangent line at 4, 2. Here it is. And the slope is positive. It looks like it's a little bit bigger than 1. You know? Kind of, I don't know, kind of just sailing up like that. A little bit bigger than 1. Well, now I have to plug in the points, and I got to plug in the whole thing. Okay, so I plug 4, 2 into the derivative. So I'm going to have negative 4 squared plus 3 multiplied by y, which is 2, over y squared, so 2 squared, minus 3 times 4. Well, negative 16 plus 6 is negative 10. And 4 minus 12 is negative 8. So the slope is 5/4. Let me write the line. We got x minus the x coordinate plus the y coordinate. There's our tangent line. And as we said, it looked like the slope was a little bit bigger than 1. It came out to be just a little bit bigger than 1, 5/4.